Hello everyone, welcome back to our channel students. So in our previous video we have got just the introduction of group 15 elements, so that is the nitrogen family. So in this video we are going to talk about some important compounds of nitrogen family. So the most important compound, or one of the most important compound of the nitrogen family is dinitrogen. Clear? So now let us see in this video how can we prepare dinitrogen. Generally it can be prepared commercially by two processes. One is liquefaction and one more is fractional distillation. Clear? So let us look at the preparation of dinitrogen. Commercial preparation. Commercially we have two methods in this. One is liquefaction and one more is fractional distillation of atmospheric air. Yeah. So this is the important one, fractional distillation of atmospheric air. So we know that atmospheric air mainly consists of oxygen and nitrogen. Here we even have carbon monoxide, carbon dioxide, and we have some more impurities also, but we will be focusing on these two, oxygen and nitrogen. So the boiling point of these two, that is oxygen, is 90 Kelvin, and whereas the nitrogen is 77 Kelvin. Yeah, so you can clearly see that there is some difference between the boiling point of oxygen and nitrogen. So on applying fractional distillation principle, see, this nitrogen will get distilled out first. Yeah. So this distilled out nitrogen will be separated out and purified, and we get the pure nitrogen. This is a commercial process. So it requires huge amount of money. That means it is economically difficultly clear. So in order to prepare dinitrogen in small quantities, we will use the laboratory methods. This is the commercial preparation. And in laboratory, that is small scale preparation, we can prepare dinitrogen by treating ammonium chloride. This is the first one. This is the first method. We will treat ammonium chloride with sodium nitrate. Yeah, when we treat this, we will get the pure nitrogen and some molecules of water and sodium chloride, that is a salt. Clear? So this is a simple method of laboratory preparation. We treat ammonium chloride with sodium nitrate and we get the dinitrogen with water and sodium chloride. But what we get this dinitrogen is actually impure. It is impure. Clear? So this consists of NO and NH3. Clear? So this is impure. So this can be purified by treating it with sulfuric acid and potassium dichromate. Yeah. So this impure dinitrogen can be purified by treating the same impure dinitrogen with sulfuric acid, and which also consists of potassium dichromate. Clear, students? This is one of the first method of preparing the dinitrogen laboratory. We can prepare this dinitrogen laboratory by using ammonium dichromate also. Clear? So second one is by using ammonium dichromate. By using thermal decomposition method. That means we are just heating this ammonium dichromate in order to get our nitrogen. Now let us look at the reaction. So we have ammonium dichromate. We heat this ammonium dichromate, we will get the nitrogen, dinitrogen, some water molecules and Cr2O3 as the byproduct. So this is the second one. That means we are just thermally decomposing the ammonium dichromate in order to get the dinitrogen and 4 molecules of water and Cr2O3 as the byproduct. These are the two important methods of preparing dinitrogen laboratory. Now let us look at the properties of dinitrogen. The first property of dinitrogen is it is colorless. Clear? So you cannot see the gases, right? You cannot see the atmospheric air, clear? But you can just feel it. Okay? So dinitrogen is colorless and it is odorless. It is tasteless also. Clear? So it is tasteless also. But the main important characteristic or the main important property of dinitrogen is this dinitrogen is inert at room temperature. Inert at room temperature. Why it is so? Why dinitrogen is inert at room temperature? It is because dinitrogen exists in the form of like this. Clear? So dinitrogen is a triple bonded to nitrogen. Clear? N triple bond N. So it requires more bond dissociation enthalpy to break these 3 bonds. Clear? So more energy is required. So generally this one is very difficult at room temperature because it is only at room temperature the dinitrogen is inert. Why it is? Because it is having the triple bond, so it requires more bond dissociation energy in order to break these 3 bonds. So here, so at room temperature that particular bond dissociation enthalpy will not be available. So dinitrogen behaves as inert gas in room temperature. But if you increase the temperature, bond dissociation energy increases and easily can break this. Clear? So inert property will go from this. So these are the main properties of dinitrogen. The main use of this dinitrogen is used in the manufacture of ammonia. Manufacture of ammonia. Clear? So the famous process is Haber's process. Yeah. So these are the properties of dinitrogen. We need more focus on this one, inert characteristic or inert property of dinitrogen. Now let us look at the next important compound in nitrogen family, that is ammonia. Yes, students, the next important compound in the nitrogen family is ammonia. Clear? Ammonia is easily available in air also and even in soil also. But you will get ammonia by the decay of urea also. But we do not require all those things. We just let us come to the point directly. So now, according to your syllabus, now let us focus on the preparation of ammonia by a very important process called Haber's process. Clear? So this is the preparation clear? So this is the simple representation of the Haber's process. We will discuss it later. So now let us look at the typical reaction which involves in the Haber process. So the typical reaction as the dinitrogen we have prepared in our previous slide here. So we use that, it's a gas, and when we treat with the hydrogen, we will get the ammonia. Clear? So this is a very important reaction. So it is a reversible reaction also. Clear? So in this, the delta H is minus 46.1 kilojoules per mole. That means it is an exothermic reaction. It is an reversible reaction also. So this reaction is very typical. It will not occur very easily. So we have some conditions. We need to create some conditions in order to make this reaction possible. So those conditions are governed by a scientist called Lee-Chetelius principle. Yeah. So according to Lee-Tetieri's principle, in order to have this reaction, the temperature should be 700 Kelvin. It is a very, very important question from the point of your board examination, be careful students. So according to Lee-Tetieri's principle, the temperature has to be maintained at 700 Kelvin, and the second one is the pressure has to be 220 to 10 to the power of 5 pascals, 200 atmospheric pressure. Here, and the catalyst we use is iron oxide F. Iron oxide with K2O and Al2O3 as catalyst, and we will use molybdenum as catalyst promoter. Yeah. So these are the 4 important points in this one. So this reaction is favored only on this condition. Okay, these conditions are favored by Lee-Tetieri's principle. According to this principle, the temperature should be 700 Kelvin. The pressure should be 20 to 10 to the power of 5 pascals, or simply 200 atmospheric pressure. And we will use iron oxide as the catalyst, and we will use the molybdenum as the catalyst promoter. And this is the typical reaction involved in this, and finally we will get the ammonia. Clear? So now let us focus on the representation of this Haber's process. See, here we are passing hydrogen and dinitrogen through this, and the hydrogen and dinitrogen will be compressed by a compressor, because we need to maintain the pressure of 200 atmospheric pressure. Okay, clear? So in order to get this pressure, we will use the compressor, and these two are compressed to 20 to 10 to the power of 5 pascals here, and then after this compressed hydrogen and dinitrogen will send to the catalyst. Okay, this will be treated with the catalyst iron oxide, and finally you will get the liquid NH3, liquid ammonia. Here we will be having N2H2 and NH3 also. Yeah. So after we treat the compressed hydrogen and dinitrogen with the iron oxide catalyst, we will get 3 products. Okay, one is we will get the pure ammonia, and also we will get the hydrogen and dinitrogen also. Clear? So this NH3, that is ammonia, will be separated out in a separate beaker, and the left end and this nitrogen and dinitrogen and hydrogen, which is not reacted to form ammonia, is again sent out, then it is pumped back, and again it will be reacted with iron catalyst. Clear? So the process is continuous, and the same thing will happen, and finally we get the maximum amount of ammonia. So this is the simple working condition of ammonia by Haber's process. Is coming to its properties, the properties of ammonia. First of all, ammonia is a colorless gas. Ammonia is a colorless gas. Clear? And second one is, it is not odorless, it is having some odor. This is actually a pungent smell of odor. Okay? And ammonia is highly soluble. Highly soluble. Why it is so? It is highly soluble in water. This solubility is based on the hydrogen bonding. Coming to the representation or structure of ammonia. Yeah. We have so this is the simple representation of ammonia. Nitrogen, it is bonded with 3 hydrogen. We have a lone pair of electrons. Clear? Lone pair of electrons is there. lone pair of electrons is there. So as it is, this nitrogen is more electronegative compared to hydrogen, it will acquire partial negative charge, and these hydrogens will get partial positive charge. Due to the difference in their charges, there will be hydrogen bond in ammonia. Clear? So the solubility is due to the formation of hydrogen bond. Hydrogen bond. Clear? The fifth property is the boiling point is high. Boiling point is high. The same thing, it is also due to the formation of hydrogen bond. Clear? Yes, ammonia it acts as a base. Clear? Ammonia acts as a base. Clear? Actually, it acts as a Lewis base. Why it is Lewis base? Because it has a lone pair of electrons, so it can donate this lone pair of electrons. So it acts as a Lewis base. Now let us prove how ammonia acts as a base. It is when ammonia is treated with water. Here, when ammonia is treated with water, it forms ammonium ion. Here, so it forms ammonium ion. That means it is accepting an hydrogen atom. So it acts as a base. Clear? And next one is when this base, when this is a base, when it is treated with an acid, like hydrochloric acid, it forms a salt. This is base. This is acid, and it forms a salt. Yeah. So it is a Lewis base. It is a Lewis base. Why it is a Lewis base? Because it can donate the lone pair of electrons which is available. So, and this is the seventh property. And next one is it can use to identify the metal ions. Clear? For example, in order to know the copper ion, when copper ion is treated with, just a second, let me write here. When copper ion is treated with ammonia, it forms deep blue cypromonium ion. Here. Yeah. So by this we can able to identify the copper ion also. If you are not able to read this, if you are not able to see this, I will repeat it again. So when ammonia is treated with copper 2 plus ion, it forms CuNH3 4 times of 2 plus, that is deep blue precipitate of cypromonium ion. So by this we can able to identify the presence of copper ion in that particular unknown compound. Clear? So these are the properties of ammonia. In this, the preparation of ammonia by Haber's process is a very important question by the point of your board examination. Now we are ending up with these properties. Thank you, students.